customer recently left a pretty funny 5-star review for an 8-inch wall speaker. They wrote that the staff was less than friendly, but answered my question.
Which, kind of makes you wonder why a simple wall speaker needs a call to tech support in the first place.
Right, like what makes it so complex?
Yeah.
Well, in today's deep dive, we're looking at a product spec page from HDTV Supply. They're a 25-year-old AV retailer, and we're looking at the advanced network devices. IPSWS-SM IP speaker.
That is definitely a mouthful of a name.
Totally. But our mission today is to explore how those clunky, crackly public address systems you probably remember from high school have, well, quietly transformed into these sleek, smart IT network devices.
Yeah, and that frustrated tech support call actually makes perfect sense once you look under the hood. I mean, we aren't just talking about a magnet pushing a paper cone anymore.
Exactly. So let's start with the physical hardware. In the past, running audio meant pulling really expensive analog speaker wire, plus, having an electrician run dedicated high-voltage power lines.
Right, to power the amplifiers. But this specific speaker uses something called PoE, or Power over Ethernet.
Okay, wait, let's unpack this. Power over Ethernet.
Yeah, so it only needs a single standard Cat5 data cable and an RJ45 connector. That is literally the exact same plug you'd use to hardwire your desktop computer to a router.
Wow, really? Just a basic network cable.
Just that one cable. And that single data cable powers a 95 decibel output using just 8 watts of power. There were no special servers, no dedicated audio amplifiers needed.
I have to admit I'm a little confused. How does it physically get enough electricity to blast 95 decibels? Because, I always thought an Ethernet cable was strictly for transmitting digital data.
Well, that's the whole beauty of power over Ethernet. Inside that Cat5 cable, there are actually multiple pairs of tiny copper wires.
Oh, okay.
Right, so some of those pairs are dedicated strictly to carrying the digital data packets, while other pairs are simultaneously carrying a low-voltage electrical current.
Ah, I
Yeah.
see. So it's a bit like, say, the USB-C cable sitting on my desk right now. Inside the casing, it has specific pins and wires routing the power to charge my laptop, while totally separate wires handle massive amounts of data at the exact same time.
That is a perfect analogy, yeah.
But here we're scaling that concept up for giant auditoriums and community rooms.
Exactly, and doing it over much longer distances, which ends up saving thousands of dollars in electrical work. You just plug in the network cable, and the device has both the juice and the information it needs to run.
So because this speaker is already drawing its power from the IT network via that copper wiring, it naturally inherits the network's brain too, right?
It does, yeah. And that completely changes how you manage it because it sits on a data network. This device, which retails for about $440, actually has an onboard web server.
Wait, why on earth does a speaker need a web server? That sounds like overkill.
Well, think about the old way of doing things. If a speaker in a gymnasium broke, a facility manager had to grab a ladder, climb all the way up to the ceiling, and manually test the wires.
Oh, man.
Yeah, that sounds terrible.
It was. But now, an IT admin can just open a web browser from a laptop in a totally different building, ping the speaker's IP address, and trigger built-in test tones remotely to run a diagnostic.
Okay, here's where it gets really interesting. That completely eliminates the physical labor of troubleshooting.
It goes way beyond just troubleshooting, too. It also supports multicast routing.
Multicast routing.
Yeah, so instead of hardwiring a bunch of speakers together on a single circuit to create a physical zone, multicast routing is a network protocol. It lets the speaker digitally subscribe to specific audio streams.
Oh, so you don't have to wire them physically into groups.
Exactly. An admin can group speakers virtually, like putting all the first-floor hallway speakers in one group without touching a single wire. It even interoperates seamlessly with Cisco VoIP networks.
Meaning it talks directly to the building's digital phone system.
Right. And I noticed in the specs, it also has a built-in microphone for two-way communication.
Wait a second. If this 12 by 4 by 12-inch box has its own web server, a unique IP address on the network, and a microphone, are we basically hanging undercover computers on the wall?
Yeah, that raises a really important point about how we define infrastructure now. If we connect this to the bigger picture, you've just hit on the exact paradigm shift happening right now.
A total merger of physical facility management and IT.
Exactly. It's no longer just an audio tool. It is a fully functioning network endpoint.
So what does this all mean for you, the listener? Well, the next time you are standing in a large building, like a hospital, a school, or an office, look up at the ceiling or the wall.
Yeah, take a close look.
You aren't just looking at audio equipment. You are looking at the physical extension of a data network.
The structural skeleton of the building is quite literally online, which leaves us with a lingering question for you to ponder. If traditional building hardware, like a standard wall speaker, is now a fully functioning IT device, well, who is ultimately responsible for the physical world around us now?
That is the big question.
Is it the facility manager with a toolbox or the IT admin with a keyboard?